So I'm going to talk about JavaScript, the high road and the low road. We'll see which one it takes and who gets to Scotland first. Let me go back almost 19 years. JavaScript is almost a sophomore, which means a wise fool. And I'll say some things about web developers because I think you guys are all web developers. And I have been a developer who cares about the web, even though my web development is limited and has been limited for a long time. If you see a Netscape homepage with like dancing bears on it, that was a joke page. That's not my real page. Web development's always been hard, and it still is. I would say it's not the easiest platform, just because there are things like old versions of bad browsers out there, let's say. There's a lot to do on the web, and sometimes you have to do it with one hand. You know, Anakin, he's kind of a crybaby there, isn't he? Is this guy is that Lord of the Rings or Game of Thrones? I don't even know. And then there's Luke. And then there's my hero and avatar, Ash, from Evil Dead 2, also known as Army of Darkness. And so to be a web developer, you have to be tough like Ash. Like, chainsaws are on aisle 6. You know, walk it off. So yeah, JavaScript is kind of the chainsaw you have in place of a hand on the web, which can be good when you're going through a bunch of deadites. That was me after 10 days in May 1995. The history is pretty well known, and I've recovered. My hair got better, too. I don't know what's going on with my hair there. I think there's some product in it. I think Vince had some product, too. We were both so thin. Yeah, Morrissey, and then Ash. His hand got better. OK, enough fun. The high road for JavaScript is actually very visible now. It's like a good walk in the Alps. It's called ES6. It's part of the Harmony agenda. After we healed some rifts and got everybody in the standards body, the so-called ECMA TC39 standards body cooperating. And so ES6 is actually happening. It's in the top browsers. The Microsoft team is doing great work in Chakra. I think you may not see this yet because it needs to come out in an IE12 preview, but there are pieces of it in IE11 even, which is pretty cool. And for going from not releasing an Internet Explorer for years to going every year is, I think, good progress. This is kind of an eye chart. I won't test you on it. I think you guys know what's here. I've talked about it over the last couple of years. And a lot of it is already in top browsers. Some of the things that I will single out as we go have to do with modules and the module system. But there are lots of things in ES6. It's a pretty beefy spec. It's the spec where we actually do more than just add library affordances like we did in ES5. ES5 started out as ES 3.1, and it grew. ES6 is where we actually make substantive changes to fill gaps in the language, not to turn it into any other language or make it be something it's not, just to look where the developers are having to use a precompiler or a transpiler or stand on their head and spin around or chop off their hand and put a chainsaw on, and instead give them nice affordances in the language. And in particular, outside the language. So here's something I want to highlight. This is a design I think Dave Herman has worked on, also Yehuda Katz of Ember, and Sam Tobin Hochstadt of Indiana University. When I did the script tag in 1995, right after those 10 days of language runtime development, I had to wedge JavaScript into HTML in a way that wouldn't show through to old browsers. So I had to deal with how to add markup whose content could be hidden. And I came up with some two-way comment hacks that to this day still work. no one has extended script since Netscape 3 when I added source equals, except to do things like the async and the defer attributes, which you should be using. I think you should be using async these days. But people forget, and so Steve Souders and others always find top websites that are janking their page load because they have a script that's not async that should be. And that means because that script might generate some content, document write or DOM construction, the whole page rendering process is stalled until the script loads. Module is a proposal that I think we can get into HTML, the living document, and into top browsers very quickly. It is just like script. It even has source equals, but it doesn't need you to remember to put async on it. It's async by default. Even when it's got inline contents, rendering can continue past it because it only is a module body. It's like what NPM has in Node.js. Everything's a module, which means you can import instead of doing this system.import call. These are equivalent. And you'll see there's a .then in the imperative form, the API form. There's a use of a promise. I also have a little arrow function, which is one of those new things in ES6. Pretty much like CoffeeScript, fat arrow. But why write that and then jank your layout if you forget that you should do it async and do it source equals out of line? If you could use module. And if you put module source equals, you can cache the modules. We can have browser caching, and good edge caching. Module is like an upgrade on script. It's something I wish I'd done back in the incredibly rushed Netscape 2 development cycle. And so that's one of the most exciting things. And it's actually outside the language because it needs to be in HTML. It needs to provide the same kind of power you get when you're writing Node modules. So that's cool. Here's Kangax's compatibility table. It's actually not complete. You can find it. I'll give a link. My slides will be up with the video, I think, really fast. It looks kind of dismal if you look at all that red, but those are like older browsers. If you look at the column on the left, that's the Firefox Nightly, and it's getting quite green thanks to awesome work by a number of people. I like the site, Andy Wingo in particular, who works for Igalia, Spanish free software hacking group, and he is, I think, subsidized by Bloomberg in this work of basically going around to the open source engines and implementing ES6 features in them. So go Andy. And IE is doing it. V8 is doing it. It's getting there. Here's some resources. There's Eric Arvidsson, I think, is the lead now for the Traceur compiler. I think they named that when parkour was hot. It's good. It actually implements a lot of ES6. As you can see, it's the first column after the one I'm running. It's the second column over after that white space. And so it's got a fair amount of green too, and it simply compiles ES6 to the JavaScript that runs in the browser, which is sort of ES5 these days for modern browsers. I think it might require ES5. The spec that we're working on actually comes now in an HTML form, thanks to work by Jason Orendorff. And that spec is going to be published by ECMA, as they always do, as a Word document, but it'll also have an ECMA HTML version that's just as good, which is real progress, believe me. Standards bodies like to use very old formats, and there's Kangax's table. So ES7 is actually in parallel with ES6. We're trying to do annual releases, sort of like IE has moved to annual releases. For a standards body to go as fast as Microsoft is even more amazing. And ES7 really shows the high road, low road distinction that I'm making in this talk. The high road is things like object.observe, so you can have a model view controller library that automatically synchronizes model and view. And that's based on the proxy work that's in ES6. It's already in like Firefox and Chrome. But then the low road is where JavaScript starts going to Scotland faster by adding fairly low-level, almost machine-level affordances, but never losing safety or security. And one of those is SIMD intrinsics I'll talk about, and then value objects. So let's talk about the low road. Value objects is a proposal I'm championing for ES7 that it takes in a number of types that aren't in JavaScript. Right now, the only numeric type in JavaScript is this double precision binary floating point, which everyone knows doesn't work right. You add 0.1 to 0.2, and you get 0.3, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 8, or 4, I think. And it's just because there are only so many bits that it can use, and it has to round. We want more bits. Machines these days do 64 bits. We also want these short vectors, int 32, x4, and so on. We want float 32, very important for programming the GPU. You don't need 64-bit floating points. Sometimes 32 is the right answer, especially for graphics. You want vectors of those. Big num would be the arbitrary precision integer type that Python has as its default numeric type. Decimal could be pretty important, so that 0.1 plus 0.2 is actually 0.3. And you might want some others, especially for scientific computing. And I'm proposing that some of the operators not be overloadable. This is based on longstanding work with colleagues at Netscape to try to keep the language so that some rules still apply. You still have some logic laws, like the De Morgan laws. But you can overload these operators, and that's important for doing new value objects, new numeric types. And you have to be able to make an object truthy or falsy, which is interesting because everyone knows in JavaScript today that objects are truthy. But value objects would be not reference, they'd be value semantics. So they would possibly be zeros in these value objects. You have to have a 0 big num, a 0 in 32. And that is best shown by using literals. You want to be able to write these things literally. If you can't do that, people aren't going to use them. They're just going to fall back on double, and you'll get lots of precision loss errors. So there's some obvious suffixes you can use. C# has picked some good ones. Some of these are all common to other languages. If big num is important, we could use n for it. Decimal, it turns out m for money is popular as a suffix. And it should be possible to do this in an extensible way without introducing some kind of complicated staging in the compilation and evaluation of the language. One of the ideas from a recent ECMA meeting that I think is promising is to take any language token that looks like a number followed by a letter, or maybe 2 letters, any run of letters. Currently, that would be an error unless it's 0x, which begins a hex literal, or 1e, which starts an exponent in a floating point number. Any of those numbers, it's not x or e or b or o, I think for binary and octal, I think we added those. All the rest of the letters are up for grabs, and you can make them work like you want. You could make L be a suffix that turns into int64 as a prefix that's called to create or hash cons or build up another 0 value in the int64 space. There's an API that I think is promising. When you do APIs, people can start building on top of them. You can eventually get the syntax. Trying to go for syntax is too much. This is something I'm going to skip over, but it allows you to write your methods for adding numbers and points or numbers and complex values in nice bite-sized pieces that deal with the type combinations 2 at a time. This is for the binary operators. And instead of having to write one big method or pair of methods that does every possible type combination. That looks promising. And SIMD, which stands for Single Instruction Multiple Data, is also an important low-road, I would say, surface that we want to be able to cover with JavaScript. It's in all the hardware. It's in your desktops with Intel's SSE and AVX. It's in ARM with Neon. It allows you to do, instead of 4 additions in a sort of a row, it does 4 additions in parallel for a vector of 4 32-bit numbers, let's say. And it is very important to game and digital signal processing programmers and other low-level hackers. It's in Dart, which is cool, because I saw John McCutcheon of Google tweet about this, and I said, hey, why don't we add it to JavaScript? Because if it's in Dart, it has to be in JavaScript. Otherwise, Dart2JS doesn't have anything to target. And people won't use SIMD in Dart, because it won't work in other browsers. So we actually have good collaboration with Google, Intel, and Mozilla, and this is under the auspices of the standards body. And John's even got a GitHub library that emulates how this would work slowly, and we're trying to put this into SpiderMonkey and Firefox, and I think it's coming, thanks to Intel, into V8 and Chrome as well. This is coming very quickly. Now you might say, what's all this operator stuff? Why do you care? Why not just add a bunch of libraries for doing math of different types. The problem is that the high road still matters. People will hand code these. It isn't just going to be written by compilers like Emscripten, which I think you've heard of. So when you start hand coding, people fall back on double because they need to have operators. They need to have usability. Java really blew it by not having operators for big decimal, and sure enough, somebody actually saw real code that did what's shown there in red. They were doing big decimals, and they were holding the US debt or some bank's big profit margin in numbers that they added, but they wanted to use the plus operator, and so they converted them to double, and they lost precision. And they probably lost their money. So you need syntax. Syntax matters. You also need decimal. I don't know if anybody can see this. This is a real screen capture from 2010, Yahoo Finance. And people blame this on JavaScript. This is actually part of the floating point standard that all our hardware uses. Java uses it, C, C#, C++. But sure enough, there's 130.889999 there. A little bit of a problem with binary precision, finite precision floating point. Decimal would solve this. So value objects seem important, operators seem important. And where does this all go? I think we know where it goes because we're already doing it with Emscripten and ASM.js. We're already cross-compiling games for Firefox OS and Firefox and Chrome and other browsers that do well with the code that's generated. I know that places like Autodesk and Adobe are playing around with Emscripten. I'm not sure if they're going to use them in production, but there's a lot of Emscripten out there. I noticed that Kim.com in New Zealand, if you go to mega.co.nz, has a couple of Emscripten compiled modules embedded on that website. One of them is doing crypto in the browser. This is doing like private, secure against surveillance messaging. So people need performance, they need the low road. And this chart shows, if you look at 1, that means as fast as native, where native means the Clang C, C++ compiler. It's part of LLVM. It's under Apple's auspices. It's pretty popular. It turns out it's not the fastest. Good old GCC, Richard Stallman, is actually faster than 1. It's shorter than 1. And so when you compare Firefox to Clang, we're actually faster than Clang, running safe JavaScript compiled from C or C++ to ASM.js, which is just stunning. I think Clang needs to catch up to GCC on all these benchmarks, but the right-hand gang of 5 benchmarks are actually macro benchmarks. They're serious benchmarks. They're not little short things that run and have small code bodies. And that we're getting so close to native performance with JavaScript, I think confirms that JavaScript is not just a high-road hand-coded language, it is a low-road target language for compilers, as I've been saying for the last couple of years. And I think this is just going to get closer and closer to Unity over native, but safe. So let me do some demos. Enough yapping, more zapping, as Homer Simpson says. I think he was doing laser eye surgery when he said that. OK, so here is a SIMD demo from our friends at Intel. I think Mo Hagigat's going to be talking about this at Fluent. If you don't use SIMD and you're doing the Mandelbrot set at this resolution, you go 12 frames a second. If you start using SIMD, things, let me start. Things can really get better. And it's not working. OK, start over. Use SIMD. Start. And I have a demo fail. Believe me, it worked. It's not fully vectorized, so it's not going to go full speed, but turn off use SIMD, and I am dead in the water. All right. Oh, I know, I have the wrong build. This is not going to work at all because I don't have build. Bear with me, folks. Intel SIMD. I always do live coding fixes. I don't cope with demo fail well. Nightly, a.app, content, macOS, Firefox, P nightly, SIMD, and I don't need to open there. And this will work better. Oh, I'm using the same profile. Let me close this. So that proves that if you don't have these SIMD extensions, which haven't landed yet, that's in this custom build, my machine crashed due to HDMI video problems, then you end up with the wrong Firefox running, and you don't get SIMD speedups. Okay, much better. So here we are, actually not doing bad without SIMD. It fluctuates around, let's say, 15 frames a second. Right now, it started out fast. I think that was a measurement error. It's kind of trending down, so I'm not sure. Now, if I use SIMD, sure enough, I get like a 3-fold speed up because it's not fully vectorized. It should be 4-fold in theory. And I can stop it. I can say, don't use SIMD, and go back. It should fall back down toward that lower frame rate. And then use SIMD, it speeds up. OK. Nice demo that SIMD is important, kind of obvious if you understand the way the tech works, but it's good to see that the SIMD actually helps. Let me then switch to a much more fun demo. This is something I showed at a conference last year. This is Banana Bread. It's a game we've developed based on the Cube 2 engine used by Sauerbraten. It's an open source engine. And there's a bot that's going to kill me in a minute. The neat thing about this is that you can embed another game inside it. And sure enough, it's the free version of Doom called Doom. Okay, I'll get rid of this bot. And what's really cool is I can actually play the other game. So and now I'm playing the game inside the game. And to prove it, what episode should I pick? 3rd episode? 4th? I'm going to die. I'm going to do the please don't kill me. Now I'm using the arrow keys, and I think control fires, and I think there are like zombies around here. Oh yeah, there are. Are they going to kill me? Anyway, it's kind of back to the 90s here. Whoa, somebody's hitting me. Don't do it. All right, that's the inner game. What that really means is that that screen was integrated using the canvas element from HTML5, using like 100 lines of JavaScript to blend one game into another. Something that would have taken a C++ programmer a lot of work and some juggling with chainsaws to do. Suddenly you can use the web's ability to do mashups on native code cross-compiled using Emscript, and that's pretty awesome. Here's something I showed last year. Some of you have seen this, but it always gets people wound up. This is the Unreal Engine 3 from Epic Games. We announced at GDC last year. I showed it at Fluent last year. And it's a good shooter, so I'll just have fun with it for a little bit. And then I'll show you Unreal Engine 4. So this is the Sanctuary level from Unreal Tournament. Fly through gaming. 60 frames a second. An important low road affordance here, that's my rockets, is WebGL. You want to have the full power of the GPU on your side. I'm not very good at this. That's why I'm in God mode. Also, you need a mouse to play these games competitively. I learned that the hard way at Netscape, where I wasn't very good either. All right, Unreal Engine 3, Unreal Tournament, cross-compiled to the web. No plugins, pure JavaScript, runs very well in Firefox, runs pretty well in Chrome, has a longer startup pause. But V8 is catching up with us. It's nice to have the shoe on the other foot there. And then this is more of a cool down for you guys. This is the sole demo level for Unreal Engine 4. This is the first time this is being shown. I'd like to thank Epic for letting me show it. And it's awesome. It's going to take a minute to start. This is a big level. It's still being worked on. There are some areas where you'll see a transition that's a little bit janky, and that's because the game's not done yet. And it's not a shooter, so it'll be very mellow. Let me see if I can get back into, I want to get out of this and do my full screen thing here. If I can do that, thank you very much. All right. I'm going to follow this little flying guy. He's going to help me. You can tell this is a more advanced engine than Unreal Engine 3. Really beautiful lighting effects. And we'll get to the city in a minute. Unreal Engine 3 is out there, right? It's licensed to a lot of games, so I think the Nom Nom guys who did Dungeon Defender have Monster Madness coming to the web. Again, plug-in free. And the mashup ability is meaningful. If you go to a website and you can see a game embedded in an iframe and you can start playing it, you don't have to go through a scary install dialog or wait too long to get into the game. You can sort of trial it before you do anything else. Some kind of giant flying statue here. Cool. That's really important for acquisition of users. Game publishers tell us this, and I believe them. So we expect this is going to be really big. When you get Unreal Engine 3 out there, and you get 4, you get licensed people doing their games on the web, no plugins. I think it's going to change the whole landscape of gaming. Think of that plus the Oculus Rift or similar, VR goggles with your back. It's the 90s, but done right. Maybe they'll remake Evil Dead 2. And yeah, this is just beautiful stuff from Epic. No fighting, so again, it's a bit of a cool down. And here you'll see it's not quite done. There's going to be a bit of a jank here where they go through a level change. Yeah, right here, I think. But the other thing that's cool is this engine is fully toolable. If you are an Epic licensee, you can immediately freeze the game and jump into the tool and start turning off lighting so everything's flat. Or you can turn on wireframes to infinity. I've seen this. It's an amazing demo. Here's a nice cityscape. And that's another thing the web does well. It allows people to create as well as consume, and that seems super important for anything that's going to be like this, like gaming or like building the matrix. I think if I go down here, I'll get a nice view of the city, and then I'll stop. And there's another awkward transition. Some of this stuff is still being worked out. There's my little robot friend. All right, cool. That is Unreal Engine 4 in the browser, no plugins. I won't view source because it's kind of unreadable. Thanks. All right. So what does it all mean? If you take the high road and I take the low road, I'll get to Scotland in the morning. I think it means that we're finally getting the web to not be like juggling chainsaws and fighting deadites. It's got to have an end game that allows the developers to extend the platform. Not like you used to do with Java, where you wrote huge piles of code that you had to load all at once, because the web is smarter than that. We've learned by doing JavaScript incrementally how to load things fast. But to fill in the low road affordances like WebGL, like SIMD, like 64-bit integers that you need to do this amazing game and other such programming, and then to also try to explain all the legacy that's still important in HTML and the DOM in terms of the primitives as much as you can. And then also work on the high road. The high road matters too. People shouldn't have to load a ton of library code. There should be built-ins in the browsers that do the common high-level things. And what common high-level affordances you need changes over time. It evolves. So both roads lead to this Extensible Web Manifesto. You can read about it on that site. I have my name on it. And I do believe it. And there are people on the W3C technical architecture group who believe it, who are really working on it now. And we want the real end game to make GitHub where the web standards are pioneered. And that makes me think that we're really in an evolutionary system. Both roads lead to a sponge with a monkey face, or maybe a pelican that looks kind of like a bathroom fixture. But it's a very good pelican. It does what it does well. JavaScript has been under amazing evolutionary pressure. It has this first mover advantage. I didn't know. Who knew? I just was hacking as fast as I could. And it looks like it's going to reach the end game. The high road and the low road converge in a virtual machine that's really fast for native code and that has high-level affordances for the web development that you guys all love. So always bet on JS. Thank you very much.